Walk onto any modern factory floor as it lights up, and you will see glowing digital screens everywhere. They are attached to machines, mounted on walls, and stacked in control rooms, all pushing out real-time process data. Because these interfaces often share similar graphics and layouts, operators often assume that the touchscreen bolted to a packaging machine and the multi-monitor setup in a central control room perform the same role. This layout defines the two distinct domains of automation. On the left is HMI, Human-Machine Interface, which handles tactical, micro-level control of a single machine. On the right is SCADA, Supervisory Control and Data Acquisition, which provides strategic, macro-level supervision of the entire facility. These technologies occupy separate, non-overlapping levels of the industrial automation pyramid. Treating these systems as interchangeable creates a barrier to scaling production or managing high-complexity equipment effectively. Running a massive, multi-stage manufacturing plant using only isolated touchscreens forces operators to move from machine to machine to diagnose individual faults, resulting in significant downtime. Conversely, deploying high-end servers, complex networking, and enterprise licensing to monitor a single standalone boiler creates a massive overhead with no measurable return on investment. To find the right balance, we have to look at the specific architecture of both systems and where their physical and digital boundaries lie. By identifying these boundaries, you can determine whether a specific operation requires an HMI, a SCADA system, or a combination of both. Proper infrastructure investment happens when the technology choice aligns directly with the physical scale and data requirements of the operation. Every automated process begins at the floor level. Sensors and actuators interact with equipment, pushing data upward into a local PLC, or programmable logic controller. In an HMI setup, a localized connection links that PLC directly to a touchscreen mounted on the machine frame. This provides the operator with high-speed response times for starting and stopping equipment, making real-time parameter adjustments, and selecting production recipes without network latency. However, because the interface is tethered to a single controller, it remains siloed from the rest of the factory's data. These hardware-based panels also lack the processing power and storage space required for long-term data retention. HMI delivers immediate responsiveness at a low entry cost, provided the control requirements are limited to a single machine. Scaling up requires the PLC to move past the local screen. In this architecture, the controller reaches a wide industrial network. This network aggregates telemetry from dozens of controllers simultaneously, funneling that information into centralized SCADA servers. These servers rely on a historian database, a high-capacity software repository that logs and indexes years of plant-wide performance data. Centralizing this data allows remote monitoring across geographic sites, production optimization through trend analysis, and creating historical baselines required for predictive maintenance. This level of oversight requires a significant commitment to capital expenditure and a higher degree of IT complexity to maintain the server environment. Deploying SCADA provides a clear view of plant-wide performance that informs multi-year investment and maintenance decisions. The practical differences between these systems are most visible in how they handle data logging. This chart contrasts hardware limits against software scalability. An HMI offers only short-term data before overwriting old records, while SCADA provides the exponential storage capacity of a dedicated historian. Engineers use these SCADA historians to generate granular performance reports that track machine health over thousands of operating hours. Scalability follows a similar pattern. Expanding an HMI setup requires purchasing and wiring new hardware for every machine, whereas SCADA simply adds new data nodes to the existing network. Localized interfaces cannot replicate the long-term optimization capabilities of a centralized supervisor. This matrix outlines the deployment rules. HMIs are the primary choice for small-scale automation, where the operator remains at the machine. Use an HMI for standalone equipment that requires manual interaction, such as packaging machines or CNC tools. SCADA becomes necessary when an operation demands remote access, multi-site aggregation, or automated regulatory reporting. This applies to complex infrastructures, like water treatment plants, cross-country pipelines, and multi-line manufacturing facilities. In a standard workflow, the HMI manages the physical task on the floor, while SCADA analyzes the broader process from the control room. High-output facilities do not choose one system over the other. They integrate both into a single hierarchical structure. This integration is the core of Industry 4.0, where machine-level hardware and plant-level software function as a single unit. In this modern loop, HMIs handle the high-speed edge interface for the operator. SCADA then collects that data and pushes it to cloud-based platforms to analyze performance across the entire enterprise. Modern smart manufacturing relies on the synchronization of local tactical execution with centralized strategic intelligence. Transitioning from local machine control to a fully networked, data-driven supervisory system requires specialized engineering architecture. DEVI Automation Solutions specializes in designing and implementing these interconnected systems. Their engineering teams handle everything from PLC programming and HMI development to large-scale SCADA rollouts and AI-driven data analysis. To evaluate your current infrastructure or plan a new facility upgrade, you can contact the team at DEVI Automation Solutions using the email on screen or the link in the description. Working with experienced engineers is the most effective way to build reliable automation systems that increase output and reduce operational risk.